Hi, we're here this week, ePMP Now, and our topic this week is interference on your radio system, and we're going to call them the 7 sins in interference, what they are, and how ePMP successfully deals with them. I'm Dan Sullivan, and with me,
my name's Marty Gray, and I'm here to talk about problems that I'm having in my network. So we've got some interference issues. What I want to do is get to the bottom of why we're seeing these issues, Dan. So please today, if you could enlighten me, help me walk through kind of the different forms of what we're seeing. I'll sort of let you know what the problem is, and if you can enlighten me, I'll walk away a happy WISP owner.
That'd be great. Maybe what I'll do is over to the side here, we have a whiteboard, and we'll write down the problems, what the effects are, how they harm your system, and what an ePMP solution is.
That would be awesome.
Okay.
I appreciate it, Dan.
All right, Marty, so what's bothering you? What's causing you problem in your network?
Well, the main thing right now, first thing that comes to mind is just self-interference in my network. It just seems like I can't get the reliability and the throughput that I need.
You mean the people like talk over you?
Yeah,
and you
well,
hear it
like,
and
yeah,
we
when
can't
people talk
communicate?
about, well, yeah.
Wait, I got to back off a little bit and wait for you.
Yes, please.
Oh, okay, I'll be quiet.
And so this obviously is something that's very irritating to me.
Yeah, terrible.
And I bet you could help me figure this out, Dan.
Well, let's start talking like we're ePMP and we won't talk over each other. How about?
That sounds good. I'll schedule when I talk and you schedule when you talk, maybe.
Oh, good. That's excellent. So number one is even in our own radio system, we have the problem of self-interference. And the effect are collisions. And the harm of that is it hurts our ability to get data through, and also it was also affecting our latency, wasn't it? So overall, scalability is hurt. Can you imagine, Marty, if we had more of our friends here talking right now?
That would be a noisy situation.
It would be horrible. I mean, I love our friends, but if we just all chat at a party, there's only so many friends you can have, right? Okay, so what is it that we do to solve it with ePMP? Okay, so what we have created in ePMP is a TDD frame, and we have the communication structured very well on the downlink. The AP only speaks to specific subscribers, and subscribers listen. And then on the uplink, the AP tells each subscriber when it should talk.
Okay, so does that mean that we have similar slots for all the SMs? Will one SM drag us down, or how does that work?
No, actually each SM will have a different slot, as you brought up,
okay.
And that way they won't collide with each other. And as you can see, there's a little bit of red gap in between each SM. It's a little guard space just to make sure we never do that colliding problem.
I see. Okay.
And so the benefit of this is we've minimized the overall amount of downtime that we don't use in a frame.
Okay, I see.
Okay. So the solution is Cambium's TDD Mac. All right.
Okay.
What's your second problem, Marty, that's causing you problems?
Right. Well, so since we have been having problems with interference, I've gone out and I've raised up my transmit power on my SMs. And it seems like what's going on now is just I've got excessive power, excessive noise coming from my SMs. And now I'm kind of stuck. So I don't really know where to go from this point.
So in other words, now because your SMs are really reaching your AP and they're really hot, it causes problems on your neighboring APs or neighboring sites because they hear them too.
That's exactly right. It's driving me crazy.
Oh my gosh, yes. So problem number 2 is our SMs transmit is too high.
Exactly.
Right? And so the problem, once again, that you're experiencing is it causes noise pollution.
Okay.
Okay. All right. And the downside of that is it affects your throughput, decreased throughput for your other access points.
I hear that.
Okay. So what is it that we do with ePMP? ePMP has a feature called Automatic Transmit Power Control. And simply what that is, at my AP, to have a successful signal, I only really needed to get there at what, neg 60 dBm?
Something like that, yep.
So I can tell each subscriber, a close-in subscriber, really turn your transmit power down so you get at neg 60 to me. And the far-away subscribers, I can tell them to turn up as much as possible to get to neg 60.
I see.
But there's no noise in excess of neg 60.
So that means the close-in SMs won't be blasting away at the AP anymore.
That's right. That's what we have.
That would be awesome.
Okay. So our solution is transmit power control. All right. Marty, what's your next problem at your site?
Okay.
It's your WISP.
Well, everyone needs access. Everybody has things on the internet right now.
Okay.
So it just seems like right now in this radio environment, we've got a lot of people talking, a lot of other interferers out there. There's other wireless operators are putting up equipment all the time, and it's just messing us up. I've tried to talk to them, I've tried to reason with them, but now what we have is everybody's blasting away. I've got interference coming from outside of our network.
Okay.
What's the deal?
So what is the problem? Well, so now the problem here is we just had other interferers, and we're in the unlicensed spectrum, and that problem is never going to go away. We can work well with our neighbors, or maybe they don't want to work well with us, but no matter what, you still got the problem.
Right.
All right. So I'll capture this problem as other interferers, and they're screaming at us. And the issue here is it raises the noise floor. So the more they talk louder and louder, and it hurts your ability to hear your signal. Okay, so the effect is it raises our noise floor. And then the downside of that is also decreased throughput. So what we did with ePMP to address this issue is two things. We have two features in the product. One is called ARQ, and simply what it is an automatic repeat request. And simply what ARQ does is it has the packets be resent if for some reason they don't get through. And this often occurs due to having an interfere just appear out of nowhere.
So if the message doesn't make it, we try again, and that increases the reliability.
Absolutely, and we always get our message through. We were like the mail service back in the early days of the in the Pony Express, the 1850s. We always get our message through.
Yep, those were better days.
Better days, better days.
Yes.
Not as many interferers back then.
No.
And so the other thing that we do is we have a feature called rate adapt. So sometimes a message can get through and at a high MCS or modulation encoding scheme, sometimes not so good. But our algorithm figures it out and to do two things, to optimize throughput and to minimize latency.
Okay.
So it's been tuned. So we have those two things to deal with it. Our solution is our proprietary ARQ and rate adapt algorithms. Okay, what's the next thing on your mind, Marty, that's causing you problems with your system?
I know, it seems like I've got a lot of problems here, but since I've got you with me here, I'm going to lay it all on you. So the other problem I have a lot of sectors. We need to serve a lot of customers. So we have sectors that serve people to the north, to the south, to the east, to the west. It seems like the problem now is between sectors, we're seeing some interference. So this is something for us, it's a little different than just a general noise floor problem. It's something that we're doing within our system between our sectors that's making an issue here.
So you have these beautiful APs. They're absolutely lovely, but they're not coordinated all the time. That's the issue.
Yep.
You got this four sites AP or a sister site, and they have conflict.
That's
so
exactly
it's like you
right.
need a really good parent or mom to like organize them and make sure that they coordinate their activities together.
Right.
I see. Yes. So back to now, it's not just self-interference. It's self-interference though at a system level. So it could be that we interfere within the same tower, self-interference, or what we do is we interfere between different towers.
Yeah, exactly.
Okay. So what this does is it causes collisions between your access points. And the collisions between your access points, the only way to solve that is you have to increase spectrum. You have to separate, like you're separating your APs and spectrum, you'd have to separate your children to avoid the coordination. But if you coordinate together, look how close they're standing together, these beautiful girls.
I see.
You could do the same thing and get your APs close together in spectrum.
Okay.
So the downside is you need a lot of increased spectrum.
And that's not doable for us.
Because you're out of spectrum and you got your neighboring competing other providers also using up your spectrum.
Yeah, we don't have everything to work in. We need to make sure we use our spectrum efficiently.
So what ePMP does is we have GPS synchronization where we can coordinate the transmit and the receive cycles. So instead of having to have 20 megahertz or 40 megahertz of guard band between each AP and have the APs on different channels,
which isn't always realistic for us.
No, you run out quick, don't you?
Yes.
What we do is you can reuse just 2 channels and have an AB sector at only 5 megahertz of guard band.
That would make it a lot more easy for us to get out and possibly even deploy more.
Yes, absolutely. And you could have more sectors and more rings of AB configurations, more customers, and hence more revenue. So just as a little explanation here, if you look at how much channel bandwidth is needed on a GPS sync system to do AB, or 4 APs on a tower, you only really need 45 megahertz of spectrum. And let's say you get 90 megabits of bandwidth within the system.
Okay.
That means we can get up to 8 bits per hertz. But if we aren't able to do the frequency reuse that ePMP provides with GPS synchronization, then we need up to 200 megahertz of spectrum, which we might not have, or you might not have, Marty.
I hear
and
that.
It decreases your throughput down to 1.8 bits per hertz.
Okay.
So we are high, or if we had 4, this is 40 megahertz of guard band.
Okay.
It's highly, highly more inefficient.
I see.
I see. So
Okay,
our
yeah.
solution to the whole thing here is GPS sync. Okay, not Marty. Now we got GPS sync going. What's the next problem that you're experiencing?
Right. Well, it seems like I've got radios that are transmitting that are making some kind of effect on the backside of my access points.
A backside problem.
So the issue is I need to have these radios out there serving customers.
Okay.
But I also need to have sectors all over the place to serve everybody. So what do I do about receiving interference on the backside of an antenna?
Well, our systems work best when they have a high front-to-back ratio between the front AP and the back AP. So it's almost like if these 2 women here were talking with each other, one of them would talk really softly and the other one, and it would like not interfere with the communications of the other woman who she's talking with someone down there. She has someone she's talking with, the other woman is quiet, and so then it doesn't interfere with the communication.
I see.
So that's what we need, is we need antennas that make sure that the other AP doesn't hear the communication from this AP.
Oh, I see.
So
Okay.
that's what we say by having good front-to-back ratio.
Okay.
Okay.
All right.
All right, so we'll draw a little picture of that. So here you can, well, here's a slide. Here you can see that we want to make sure that the APY's antennas, or APY signal is attenuated going to APX.
Okay.
So the SM transmits to APX and gets this really good signal and say at neg 60.
Which is great. Yeah.
But SMY, when it transmits, it's attenuated by the good front-to-back ratio of the sector antenna. And so it's received at like negative 95.
So it's inherent to the antenna that causes that attenuation on the backside.
That's right.
Okay,
The antenna
okay.
is what we use to solve it. So problem number 5 is, boy, you can do GPS sync, but if you have a bad front-to-back ratio, oh, that can cause problems. And the bad front-to-back ratio causes an increased noise floor that you have caused yourself,
Oh.
right? And the increased noise floor, that causes overall decrease in throughput. And the solution is our cambium sector antennas because they have great front to back ratio. All right, Marty, what's your next problem now that we've got that solved?
Okay, I really have 2 more things to complain about, Dan, and you've really been answering my questions, and I appreciate your time. So nowadays we share some space on the tower. We've got some buildings that we share space. So we have other radios from other companies that are actually co-located and kind of, in terms of RF, they're close to us as well.
It's sort of like this background we're looking at today. There's too many radios in a location, and they're all like screaming.
That's
that
exactly right. Yes.
So problem number 6 is we have other radios screaming right near us, and we hear them.
That's right, and it's causing us troubles. So.
Oh, terrible. Okay, so what we have a solution, let's capture that, is we have loud interferers, or loud radios co-located with the AP. Okay?
Exactly.
All right. And what that does is it raises the uplink noise floor, and it's hurting your throughput, your uplink throughput. All right. So our solution to that is ePMP intelligent filtering if you get an ePMP 2000. So you can see a very noisy spectrum. There's only a little bit of space available where we detect this, we do a clean channel.
Okay.
We select that channel, and in a normal radio, what happens is the interferers, it still hurts us. They're screaming at us.
Right.
But with ePMP's intelligent filtering, ePMP 2000's intelligent filtering, we have a dynamic filter that wraps around the channel, and it protects you from those screaming radios.
I see. So we're kind of casting away the radio signals that are causing us trouble.
That's right.
Around our intended
We have a very tight dynamic filter. You can change to whatever channel you want, and now you're protected with ePMP 2000.
Okay, I see.
So we have ePMP 2000 intelligent filtering. And Marty, you have one more problem. What is that problem?
I do. So now what we have is some interferers that are on the ground that are seen by the AP.
Okay.
And it just seems like this is what we have to deal with now.
Yeah.
But I don't want to deal with it because it's causing me to lose sleep at night.
You got this big, nice sector antenna, but it works so well it sees your interferers too.
That's exactly right.
The whole 90 degrees.
Yes.
Oh my gosh.
You're able to say it well, Dan.
Okay.
Yeah.
All right, so we show a picture here, and it's like, that's the view from the AP. I could never stand up there. The heights would kill me.
Yes.
But it's like you see everything. You're getting every bit of noise.
Right.
That's
right.
the problem. Okay, so we see all interferers is the problem at the AP. And it's causing you an increased uplink noise floor, and that is decreasing your uplink throughput also. So the solution comes back to ePMP 2000. What we have is we have smart beamforming. And so we might have an interferer within the sector as shown in this diagram. And we have different subscribers that we want to talk to. And so what we do is we have a directed beam that goes to the intended subscriber and away from the interferer to help you to get the increased throughput that you desire as if you were living more in a clean environment.
So this is something that occurs on the uplink, is that correct?
That's right. It happens on the uplink. Very good point. So this is the solution is ePMP 2000 smart antenna. Now, Marty, how's been your experience in life since you've had these 7 things addressed with ePMP equipment?
Well, I do feel empowered.
Yes.
I feel like I'm ready to get out there and handle the challenges that come with deploying a radio network in today's environment. I feel like I do have some tools to make our customers happy and some great techniques, and I can walk away feeling just a little bit smarter, which I needed anyway.
Excellent. So as you see the needs of your customers with throughput and latency, throughput increasing and latency decreasing, these tools help you to keep meeting their ever-increasing needs with ePMP.
Awesome.
All right. Well, Marty, thank you. I'm glad you were
Thank you
able
for
to
your
share
time,
your
Dan.
issues.
Yes, yes.
Hopefully, not only the issues that you dealt with, but anyone watching, ePMP will help you to meet your needs too, to fight the interference demons. Right. Bye-bye.